Well, good morning or good afternoon, depending on where you are. Welcome to our Penn Alumni Water Forum Speaker Spotlight. We have a great webinar today. It's on the future of water reuse. I am Howard Newkirk. I am the founding director of the Water Center at UPenn. And thanks to the Penn Alumni Water Forum and the Wharton Club of Philadelphia for their support in putting this event together. Also, my deepest thanks to Joanne Spignardo and Emma Dennison for their behind-the-scenes work. They're here somewhere, I know that, and in putting this webinar together, and so much more for what they do for the Water Center at Penn. Emma, could you move my slide to the next one? Just to give you a little background on the Water Center, we are Penn's hub for regional and global leadership in applied water research and policy. Our goal is to future-proof our world's natural and built water systems. We believe that water and sanitation are fundamental human rights. We help cities and communities create climate-resilient, sustainable water systems, and we mentor the next generation of water industry leaders. Next slide, please. Why water reuse? Well, as water scarcity intensifies and the value of water becomes better understood, innovative solutions are emerging worldwide across industrial, agricultural, and municipal sectors to create water supplies that are both resilient and sustainable. Even in the water-rich Northeast region of the US, new demands from data centers and concerns about water quality or scarcity can create highly localized capacity constraints, making water reuse an increasingly attractive alternative. For instance, DC Water recently announced plans to explore treating effluent from its Blue Plains wastewater treatment plant for indirect potable reuse in the city of Washington, DC, providing a backup supply to drinking water sourced from the Potomac River. Looking more globally, we are working with our friends at leading utilities of the world and Global Water Intelligence to explore how emerging technology can address many of the challenges posed by climate change. New technologies that have the potential to significantly reduce uncertainty, build public trust, and support informed decision-making. Our moderator for this webinar is Jon Freedman, and Jon leads global policy and stakeholder affairs for Veralto, which is a global leader in water technologies, water quality technologies. And prior to joining Veralto, Jon held similar leadership positions at both Veolia and before that at GE Water. Jon currently serves as on the board of directors for the Water Reuse Association, as well as serving as first vice president for the International Desalination and Reuse Association. Jon holds a bachelor's degree from the University of Virginia, a law degree from William & Mary, and most importantly, an MBA in finance from the Wharton School at the University of Pennsylvania, where he has also served many, many years as a favored class instructor at the University of Pennsylvania on the subject of the business of water. I will pass the mic over to Jon, who will introduce the subject of reuse further and introduce our other extinguished speaker today. Jon.
He's not extinguished yet.
I know he's not extinguished. What can I do?
Howard, listen, first of all, thank you for having me. And you're a friend, but you're also a legendary figure in the water industry. So having you introduce me means a lot, and I appreciate it. And since I know how the Water Center at Penn works, Joanne Spignardo probably told you should have me to speak today. So I also want to thank Joanne and Emma and all the other people who work at the Water Center. And as you said, Howard, you all do incredibly important work on the global stage on one of the major issues of our time. So thank you for everything you're doing and the team is doing there. I know that
people back at you, Jon, and I'm going to sign off here.
Okay, thank you, Howard. I know that there are a lot of people on this call are coming at water from all different backgrounds. So I think it's important we start by answering a fundamental question. Why are we even talking about water reuse? And Howard, you mentioned some of the issues about data centers driving a need for greater water and that kind of thing. I'm just going to zoom out for 1 minute and just say, look, when you look globally around the world today, there are 2 billion people in 40 countries who are living in areas that are chronically short of water. And if you ask experts at places like the World Bank or the United Nations, you will hear them say that this scarcity is very likely going to increase in the near to mid-term, driven in large measure by climate change, which is making many parts of the world hotter and drier. But it's not all woe is me. We can actually do something about this. And the good news is that we have virtually all of the water we need in the world to supply these 2 billion people with water, to meet future needs, to fuel the AI revolution by providing water for data centers and everything else by tapping into wastewater and reusing it. And when I say reusing wastewater, I mean we have all the technology we need today to literally strip out the H2O molecules, leaving everything else behind, and using those molecules to do things like grow crops, which, by the way, in the developing world is 70% of water usage, or to run power plants, which here in the US and much of the developed world can be 40 to 45% of water usage, or even to directly fill drinking water reservoirs, like we're in the process of doing here in the US in San Diego, for example, today. So great news, but here's the thing, even though we have all this technology, even though we have 2 billion people and growing who are facing water scarcity, we're only reusing about 5% of the world's water today. And if you strip out the undeveloped parts of the world that aren't even collecting and treating their wastewater, and you focus just on the developed world, we're only reusing 10% of our water today. Well, why is that? If you ask me, I mean, there are a lot of reasons, but I think the main reason is economics. It is simply cheaper to keep taking water from the ground or a river where it might be free, or even from potable municipal systems where water tends to be almost universally underpriced, than it is to implement and operate these reuse technologies. So how do we unpack this? How do we talk about capitalizing effectively on water reuse? This is basically an untapped reservoir that we can use to meet the world's water needs. We have an expert and more important, a friend, John Hanula. John is with Stantec. Stantec is one of the world's leading global engineering firms. It has a huge water practice. There are probably 3 firms, maybe 4 firms, depending on how you measure it in the world, who do as much work in terms of water infrastructure as Stantec. John has had a number of roles there. He's been the global business development executive for water projects. He's been the big cities leader. But he's an expert on all things water, and particularly water reuse. And most important, we've been friends for almost 30 years now. We've managed to, John, I don't think there's been a week that's gone by in those 30 years where we haven't spoken several times by phone or met in person. And it's been a lot of fun. And now we can add one more, hour to that roadshow. Okay, so let's start with maybe just give the audience, our listeners, 30 seconds of what is Stantec?
So Stantec is a $6 billion a year company, pretty well balanced with our consulting offerings from transportation to vertical buildings, building systems, architecture. We have an environmental services business, which does a whole lot of things. We have a energy and resources business that is essentially power. We have a water business. Our water business, again, I said balance, is about 1.5 billion globally. We have a great footprint in 5 geographic regions. North is our European business, Middle East, North Africa, Latin America, Asia, and Australia and New Zealand. So we are one of the big ones, but that doesn't matter because bigger doesn't mean better. The thing that energizes me the most about Stantec, particularly the water business, is we have so many committed professionals to solution development, using new tech, and things like water
Well,
reuse
think we have an
leverage that.
idea. I think we have a flavor of Stantec, big global engineering firm, and you're working on lots of projects and on probably 5 or 6 continents. So credentials established. Now let's start with this simple question. You heard Howard mention reuse. I talked a little bit more about it. What do we mean when we say reuse? What from an engineer's perspective, what are we talking about?
Well, let me start the answer with when you were at GE Water, when we had that branding campaign working together, used to useful. So it's really taking what was typically a liability after you treat uh, used flows, used water, dirty water, wastewater. You polished it up so it didn't impact the environment, take all the baddies out, and we typically put it in an ocean or a river course that made it go away. And that moves towards considering that water as a new water supply asset. As we get into water scarcity and are very concerned about the sustainability of surface and groundwater flows, in some urban areas, you could make up any kind of shortfall on future demand protections from water supply by taking the dirty water, the used water, and treating it so that it becomes some level of reuse supply. And John, I'll tell you right now, we got two terms. One is indirect potable reuse, or IPR. There's another term called DPR, direct potable. Today on planet Earth, about 70% of all the water that John articulated, that is roughly about 10%, that gets treated and put back in for dedicated reuse, beneficial reuse scenarios. About 70% of that gets routed towards agricultural and other irrigation. About 15% of that goes to environmental flows, ecosystem protection, seawater barriers, and those are big chunks of water. Around 12% goes to industrial users that take the feed water from a reuse scenario and polish it up to their designer water standards, whether it's ultra pure for some sort of fabrication facility or it's cooling water, but about 12% goes to the water for industry. And then a paltry 2% or even less than that goes water for people. So that's where the direct potable, or DPR, lives. And it really aligns with the water for food. You got to grow it, you irrigate, water for environment, water for commerce, water for people nexus. Those are the four principal elements, and that's where the current finished water from reuse facilities ends up.
John, and for the members of the audience, I just want to say that there is a chat box. Please feel free to ask questions. Somebody has already asked a question. We will weave these questions into the conversation as makes sense along the way, but at around 12:40, we'll also just open it up to Q&A completely. There is a question that's perhaps relevant to what you were just talking about, which is, are we considering only gray water / black water, or is industrial produced water included in these numbers? And I think when I was talking about reuse, I was talking about on the municipal side mostly. But anyway, do you want to try to answer that question?
Yeah, look, I did a planning study in China about 15 years ago where it's a brand new city and they were looking at segregating the water. And they had an industrial faction of the city. And there's the two terms are the feed water into these wastewater plants. Some of the decentralized solutions, like an industrial facility, capture their own produced wastewater and recycle it there for their own purposes. But at some point, there is discharge into a municipal treatment plant, and the municipal treatment plants get all levels of water quality from black water to not so bad water from stormwater runoff. And they're responsible for treating water at the other end of the pipe to whatever level, right? So is it a level for discharge into a water course, or do they have a side stream that is either partial or full treatment of the flows to a level that what we would call reuse, something that can be put back into supply augmentation, or even giving it to commercial institutions as feed water, again, to go through that same cycle.
Okay, so John, we're talking. I mean, the theory of the case here is there's a lot of global scarcity. There's a lot of wastewater, and we're able to tap into this wastewater to address scarcity. That's the big picture. Now, if we, I mentioned that we have all the technology we need to actually strip out the H2O molecule so you can use it for other things. You're the engineer. What are some of the major types of technologies that communities and businesses can use today to do this?
We've elevated beyond conventional treatment, right, for both water treatment and wastewater. Ultimately, it's treating water. When we talk about reuse or advanced treatment, it usually involves some sort of pre-treatment. The in vogue method right now is membrane bioreactors, MBRs. So that pre-treats wastewater flows to go into an advanced treatment train, which typically, again, in vogue, is some sort of membrane push, whether it's microfiltration, ultrafiltration, nanofiltration, or even RO. It pushes through that, takes out a bunch of stuff. That's as technical as I'm going to get. And then the final touch would be some sort of disinfection if necessary, and that would typically be UV or ultraviolet or some sort
Right.
of
So,
oxidation.
so membrane bioreactors, which is the basic building block of probably most of the reuse, certainly municipal and many industrial reuse applications around the world today, is a combination of biological treatment, where you let bugs kind of eat some of the bad stuff in wastewater, followed by membrane treatment, where you kind of physically remove the bad things that are left, followed by some kind of disinfection on the end. So that's the basic process. Um, and do you see, John, any kind of major step changes in the technology, or do you think this stuff is good enough and it's just a question of kind of fine tuning?
John, I remember vividly about 20 years ago suggesting to a municipality on a design build in California to use MBR as a treatment process, and they looked at me like it was witchcraft. You have conservative utilities that really are not necessarily early adopters to new tech. So at some point, we're going to get to a solution that involves magic dust crystals, where you wave over a dirty water tank and it turns into bottled water, right? Absent of that, we need to have proof of deployed, demonstrated results to start making municipal wastewater treatment plants accept new tech. MBRs are passé now. 20 years ago, it was a different story. The different MF, UF, NF technology, No
So
problem.
the state of the technology is pretty good. It's pretty widely accepted. Um, maybe something will come out of left field, but you don't see anything right now kind of extraordinary that's going to bring the cost down by half or something. Where we're talking about things that are incremental, at least in the near to midterm. Is that right?
What I see is new tech allowing us to maybe skip a step. Membranes that take out more so we can avoid excessive costs on disinfection. What I see is better recovery rates when the Veraltos and others, on your portfolio, you're aggressively trying to find ways to, instead of recovering 85%, we're going to be at 90%, and that makes a big difference on reducing energy costs and the residuals, because realistically there's stuff in the water, and we're concentrating it, running a secondary reuse loop on it, and the stuff in the solids becomes more concentrated, and the higher recovery rates on a single pass make it better. Look, PFAS is a great example of that, guys. you know uh, PFAS ends up resident in most of the solids on treatment processes, and that's where you handle it. But if it takes you 3 passes to get there instead of 1 pass, there's more energy units to get it to that level. So it will be cheaper when technology catches up.
Okay. So yeah, there is technology today. It's being used, but not widely enough. Uh, uh, my theory is that it's because of the economics. It still costs something to reuse water, even though it's half or a quarter of the price of desalination. It's still often more than just taking water for free from the ground and pumping it, or even from a potable municipal system. But there are some really good examples of reuse projects out there today. Can you give an example? Is there anything that you can point to where, wow, this is a pretty material example of reuse? And I'm particularly interested, by the way, in what's going on in San Diego.
Well, it goes back to necessity, right? Whether it's the Southern California story of high population growth, large economy, ability to pay, generally. I mean, we all get spoiled by cheap water, right? So we're not Saudi or some of the Middle Eastern countries where they've been
What
conditioned
is
for the
going
value
on
of
in,
water.
give me an example of somebody who's doing it right today. Orange County Water District, or you mentioned Southern California.
The whole Southern California landscape between Pure Water San Diego, and they progressively try to get their own source supply reliability by keeping some in their own reuse schemes, by adding desal at Carlsbad, which was almost half of their supply cut from Metropolitan Water District. But then let's go up to LA. I think this is a great example of
San Diego.
policy.
What is San Diego doing on reuse?
So San Diego has decentralized in 1990 when they were under the gun primarily from the Clean Water Act. So they put upstream scalping and treatment because their main plant, Point Loma, struggles to make the necessary process improvement because it's real estate limited.
But
So
San Diego's, I mean, when I read the headlines, and I don't know the details, but it says they have a $4 billion water reuse project. They're looking to do direct potable reuse, right? I mean, is that the big picture? They're
But
looking.
I mean, John, you know that we're running that program and we have for almost 30 years. Uh, it's a combination of playing completely all their conservation cards, which they did a great job on. Then it's taking some of the upstream scalping facilities, adding process to it to create more finished water that can be for beneficial reuse. So North City put almost all of North County on purple pipes for municipal irrigation systems, right? So it's a smaller plant, but it had targets and it was built into capital investment on Embarcaderos and highway medians all went to purple pipe, which is reuse mainly from North City. Then as part of the program, there are 2 additional facilities that will end up as advanced treatment facilities with targeted use. So
Can I,
if you look at San Diego's water,
but are they just a big picture for, because are they going to fill reservoirs, one or more reservoirs with treated wastewater? Is that what the plan is?
well, they're increasing the capacity with seismic retrofits on 2 of their reservoirs right now. San Vicente is the one, but yes, it ends up being supply augmentation because the term toilet to tap, which was coined in the first San Diego program back in the 90s, just speaks to the cultural headwinds of accepting DPR. Now, I think San Diego will be accepting DPR, as will Southern California, with our new regulations that we passed in 2023. You're going to see DPR in San Diego and in the LA area and even in Orange County uh, in the next iteration of infrastructure retrofits.
So some of this is, yeah, they're different. There are different layers to this issue of reuse. One is, does the technology exist to treat wastewater so it can be reused? The answer is emphatically yes. Then there are other issues like the economics. Is that a challenge? Well, I think the answer is yes, and we can talk about some ways to address that, including through policy. And one we come back to that in a minute. And then and the next layer, John, is I think public acceptance, right? So, and that's what I think you were just touching on when you said toilet to tap. That's terminology that's not particularly helpful when you're trying to get people to feel comfortable about directly using wastewater for direct potable reuse. And as the mayor of Los Angeles, former mayor Eric Garcetti used to say, he prefers to call it showers to flowers, which actually is a better term. We have a question from one of the listeners, which is direct potable reuse such a small percentage of overall reuse because people just don't trust recycling processes for direct consumption? Do you have a point of view on that? So again,
Today, yes. It's almost zero in MENA, in Middle East, North Africa, because culturally they're unlikely to accept it anytime soon. Here, it's a messaging and trust issue because people just have this direct connection to wastewater flows and drinking water, and we're not there yet. We need to get there.
Yeah. And I think in the Middle East, it's cultural and, question of law, perhaps, and religion. So Sharia, then, for sure. I, John, let's just talk for a minute about going away from the PR issues or public acceptance to the economics. You're on the board of the International Desalination and Reuse Association. I'm the president. I have to update my bio, Howard Newkrug, which says first vice president. But so the mission of the International Desalination and Reuse Association is to promote adoption of advanced solutions to address water scarcity. And you just wrote or just kind of helped publish a report written in concert with BCG, Boston Consulting Group. Do you have any thoughts on what can be done from a policy standpoint? Or you're welcome to flip it around to me if you want, since I'm a government affairs leader. But
Well, let me throw you the slow fastball, John. I think you need a champion, whether it's what the leadership, the executive leadership, the government of Singapore did to take the whole island and said, "Thou shalt." And they drove to very meaningful reuse, or what you referenced, Eric Garcetti did in LA under LA 100 on the water side. He said, we are going to take about 250 million gallons a day of discharge that goes into an outfall into the Pacific Ocean, and we're going to turn it back into the system, 100% of that by 2040. And then what cascades down is how do we do it? And then how much does it cost? So, before Eric left a couple of years ago, I mean, Plan LA is put in place about 5 years ago, and we are now in the scrum of trying to figure out what that means. And there's a program that is a genesis from that, which is called Pure Water Los Angeles. And the price tag is $26 billion to take Hyperion flows, to treat them, and have LADWP advanced treat them to almost drinking water standards and move them up to the valley for supply augmentation. It's $26 billion. And you and I were both with the head of water for DWP in the Iceland conference. And Anselmo, he knows what the price tag is, but he doesn't know what the budget is to cover that. And that's where the headwinds come.
Those who might not know Anselmo Collins is the head of water for Department of Water and Power in Los Angeles. Hey, I'm gonna. There's a lot to unpack here in what you said. So one is, Eric Garcetti, the former mayor of Los Angeles, set a goal for the city of Los Angeles to reuse 100% of its water he did this in 2020, I think. He wanted to do it by 2035, so in 15 years. He then went on, by the way, to become the U.S. ambassador to India, and was very interested in water issues there. And in fact, we gave him a white paper on how India could address its water scarcity challenges. But one of the things I think is important is that what Garcetti tried to do is set an aspirational goal to galvanize action towards achieving it. And even if you don't get to 100%, if you get to 50% or 60%, whatever it is, that's really good. And I know we have Joel Coker in the audience on this call. He's a former World Bank water leader, and the World Bank is now leading an effort to scale up reuse. They're saying from 8% today to 80%, and they're doing that in concert with other organizations like International Desalination Reuse Association and the United Nations. So setting aspirational goals can be really helpful. Another thing I just want to address for the audience is the industrial side of the equation. There was a question on that maybe 10 minutes ago. And, in the developed world, and of course, the World Bank is mostly focused on the developing world, but in the developed world, like here in the US, industry uses much more water, around 4 times as much water as cities do. But all the policies are geared towards helping take the edge off economically of the challenges cities faces. So there are grants that cities can tap into and that kind of thing, but there's nothing for industry. So one of the things we're pushing here in the US through the Water Reuse Association and some other organizations is to create an investment tax credit for industrial water reuse. So just like with wind or with solar, where these tax credits can make an industry, the economics work overnight. It's like flipping a light switch. We're trying to do the same thing for industrial water reuse. We have a bill, by the way, which has been introduced in the House of Representatives. We're trying to get it introduced in the Senate right now. So anyway, I'm just sharing that with the listeners. John, any reaction to what I just said, or?
No, I think, John, the policy enables champions like Eric or even Gavin Newsom in his 2022 plan saying, thou shalt have 800,000 acre feet of new, which is about 750 MGD of new reuse in my state of California by 2035. Aspirational, but look, what I just talked about with LA, add San Diego and everything, 75% of that's coming from Southern California. So you need to enable the champions with real policy.
Yeah. Well, listen, one of the issues that, you can't open a newspaper today or turn on the news without hearing about the artificial intelligence AI revolution. And one of the things driving the AI revolution is what? Data centers. And the lifeblood of data centers is what? water mainly
Water.
for cooling, right? So they don't overheat. Now there's some other technologies people are using, but it's principally using water for cooling. So question for Stantec, what role is water reuse playing in enabling the AI revolution?
Well, let me just kind of do a quick on, data centers. They're very thirsty facilities. They're power hungry facilities. They require real estate in areas where you can get power and water. You need comms, right? All of that stuff. So there's staggering projections on what we need to do to our water and power systems to accommodate where this is headed. But the AI applications in water systems, we've been selling this notion of smart SCADA back in the 1990s. And, think about your water network needing a central nervous system, data enabled. So when we used to call stuff big data, or we talked about simulations, now it's real time AI enabled uh, uh, scenario analysis of how your system would operate. And I think that's going to ultimately evolve into M to M thinking. So, what's this going to mean? It's going to mean less operators, and the ones that remain are going to be well trained to use the AI to as staff, if you will. But you're still going to need operators be to adjudicate AI recommendations. We're going to need to censor things because AI would not have any value until we go back in and do data collection at the device level, at the system level, run it through integration platforms, archive it, and then give it to AI so it can start giving us their version of its version of business intelligence. So we're evolving. We're figuring it out. We have an operational technology group that has been really on the forefront on how to leverage tech to drive efficiencies to the principal elements on how our systems work. And that's, operational labor, operational power, and operational consumables. So chemical use, less power generation, moving things on and off of peak uh, loads. And I hate to say this, don't quote me to the unions, but less, more well-trained, systemically trained operation staff.
Yeah. So you're seeing AI as a way to treat water more efficiently. You can actually use AI as a tool, but also I assume that Stantec is helping data centers with their water needs through recycling as well. That's got to be a growing market for you, right?
Well, we are, because a lot of the siting, the AWS or the Metas, the other hyperscalers, where they want to put some of these data centers, uh, tend to be where they can get cheap property and access to water and maybe in a power grid
Mm-hmm.
relatively close. So what happens is the new generation of wastewater flows uh, taxes wastewater plants to a point where it can't handle the extra flows. So we end up either providing a dedicated wastewater plant, and that's after we do an optimized reuse scheme inside, decentralized scheme inside the plant itself, the data center campus itself, to try to reduce the impacts to local municipal infrastructure.
I want to ask you, um, are we missing any opportunities? Are there opportunities to expand reuse? I mean, we've started out by saying we're only reusing 10% in the developed world of our wastewater. Is there some way to expand that quickly?
know, I'll tell you, you mentioned a couple things: enabling policy, economics. You go just let's just stay in the US for a second because we got a good frame of reference. And I'm going to tell you, when you look at China and India, we are dwarfed by the amount of reuse that's going on there. We are less than Middle East, but let's stay in the US. Regionally in the US, you've got arid West, so we are under the gun to accelerate reuse out of necessity, out of scarcity, out of unpredictability of long-term supply, right? It's just not going to be there. When you go back to the Northeast, not so much. There's some bellwether reuse schemes that are coming out of, like you said, decentralized schemes on big fabs or hyperscaler operations there are coming in with the playbook of decentralized reuse in there, so they reduce their impact to municipal systems on feed water supplies, on wastewater supplies. But for the large part, it's out of necessity. So the opportunity to scale, the opportunity to drive DPR comes from this evolutionary thinking, right? DPR in California is a product of us getting well beyond toilet to tap to flowers, showers to flowers, or whatever metaphor you want. We're there. California's ready for DPR, in my opinion. I don't think the rest of the country is because they never had to be. And I think that's where we got to go, is to
So you
really
think
hit the policy thing.
blowing the lid off direct potable reuse, and that you see a big growth opportunity there. Is that right?
I think you got to do indirect potable reuse before you do direct potable reuse. And I think the intermediate step ends up being something that looks like supply augmentation. So it's dedicated water supply stuff, and it runs through a water treatment plant again, right? And it blends with some sort of reservoir storage. But reuse for irrigation, why are you going to do that in New York State when it rains plenty,
Okay.
right?
Yeah. You're worried about where to put the water when it rains a lot.
Yeah.
So I've got a final question for you, but I'm going to hold it and ask it as a closing question, and just so you know what it is, and you can let it, uh, give it some thought in the back of your mind, which is, how can organizations like Stantec and other industrial players in the world best work with universities like the University of Pennsylvania and the Water Center at Penn? But we'll come back to that. And let me ask you a couple of questions that I'm seeing from the audience. So here's one from our friend Joel Kolker at the World Bank, formerly with the World Bank. I started talking about some of the gaps in terms of water supply globally and Stantec's global platform. Joel would like to focus more on emerging markets in particular, which I think makes sense given the World Bank's focus. And are there specific reuse challenges or opportunities in less developed markets? And are they specific to reuse technology, or are they more financially driven, like the lack of creditworthiness or poor regulatory regimes? So, John, you have thoughts on that, or you want me to take a shot at
Yeah, I mean, a couple thoughts come to mind. Uh, when we get like in developing countries and put treatment systems in, and John, you high pointed the fact that 50% of the wastewater doesn't get treated at all. So the value proposition, the things that the investors, even at the World Bank level, are going to look at is, okay, I need the first fundamental steps of wastewater treatment before I jump over to advanced water treatment. And then you look at the scale of some of the things that World Bank is funding, like in Bogota. You're only going to get a side stream value for a reuse scheme because they need to do fundamental primary secondary treatment right now. Okay, so that's the first thing that comes to mind. I think you look at Namibia, where they're going straight to DPR just because there is absolutely no supply resources. I like that as an example of where we can see the multilateral development banks go straight to saying, yeah, we're gonna go into this new tech. We're going to apply it. We're going to train an operations staff. We're going to skip the steps similar to what cell phones did, right? Skip the telephone poles in many countries, go right to new tech, trained operators on those systems. And I'd like to see that happen to maybe drive some of these developing countries from nasty wastewater to DPR. That would
Yeah.
be somewhere where World Bank could help.
Yeah. Thank you, John. Joel, I think of it as mainly a governance challenge. I think the technologies work, irrespective of the geography. Um, and, in a lot of the developing world or the emerging markets, they're not even collecting and treating the wastewater. So the question isn't, can we add some technology onto the back end and treat it to such a high degree that we can now use it for drinking water or something else? The question is, can we design a wastewater treatment plant in a way that will very efficiently allow for the water to be reused and so forth. So if we can get the governance right and do these things from the inception, we'll be in better shape. And in some places where they are collecting and treating the water today, sometimes there's so much lost water in the networks that to put it back into a system, you're losing 50% of it anyway. So again, governance. Anyway, there are a lot of intractable problems, and Joel Coker knows them better than most and probably knows the solutions better than most. And then we have a question from Joanne Spigonardo, who is one of our hosts, John, and she's asking kind of a follow-up on AI, the conversation around AI, and how should universities like the University of Pennsylvania be thinking about preparing students to face this AI revolution? And to engage with AI to help achieve water sustainability. If you have thoughts on that.
We started on the definition, right? Right up front, the definition of reuse. I'll argue that we need a definition which is probably organic and evolving on AI, right? It's a punchline right now of artificial intelligence, but there's so much to unpack behind that. When I look at water systems, and Joanne, I'll direct my response directly to you. I think curricula at universities need to have a 101 course on defining that. If we don't already have that, maybe some schools are ahead of the curve on that. But then, I'm going to be at a board meeting at USC next week, and I'm going to bring this up. This is a great, enlightening question because I'm going to be saying, okay, should we put a course at USC, environmental and civil department on AI applications in civil engineering and environmental engineering? And I think once we get that definition, you get the graduating students are going to come into the market, hopefully with people like me bringing thoughts on how to develop the curricula so that they plug into tactical applications and deployment of this thing that we're calling AI.
John, here's a question right in your sweet spot, I believe. It's an interesting question. So besides the obvious cost, and this is from Robert Lloyd, besides the obvious cost questions, what about space limitations? A lot of communities are already densely packed or space constrained. So how can reuse infrastructure be accommodated in this respect?
Well, we didn't touch on this idea of all the big centralized treatment facilities that were put in play in response to the Clean Water Act in 1972. And they didn't really pencil out the capital improvements until 1990, let's say. I use the example of Point Loma, which is the largest coastal treatment plant for the San Diego system. It is up against the bluffs on Point Loma. There is nowhere to put additional process trains, vertical with things. So even though that's in somewhat of a rural setting, there's nowhere to put the enabling infrastructure to do a side stream train, to do even advanced treatment to the water quality to keep them off of consent decrees. So what they do is they scalp flows into Point Loma upstream where they have the real estate, put these process trains in. I think this is an urban planning issue. And I am an architect and a civil engineer. So you can call me bipolar, or you can say that I see more of the playing field here. But I think we need to start with urban planning. I think we need to weigh decentralized systems by nature will have their own plumbing. But even some of these centralized systems to do side streams and more purple pipe and reuse, the adverse fact is you need dedicated plumbing systems. So you only end up sending water to golf courses and big industrial plans. But we need to look at this at an urban planning level, and new construction needs to have decentralized in it.
Yeah, new construction does, but it's a good question about existing urban wastewater infrastructure. And I am seeing examples, Robert, where like in Los Angeles, the county of Los Angeles, sanitation districts, they're taking the parking lot, part of a parking lot, and converting it to a water reuse facility. So different, I think communities and utilities are doing different things to kind of deal with that issue, but it's a good question. And John, there's another question which I think is really interesting, and Howard kind of had the Northeast on one of his charts in the beginning. We're seeing reuse in lots of places, not just in water scarce areas like California. We're seeing reuse in Annapolis, Maryland, and Arundel County. We're seeing reuse in Florida. We're seeing reuse in New York on Long Island, Nassau County. So the question is, what are some of the drivers, or is there a major driver? And I'll take the first swing at this, but you feel free to jump in and put a finer point on something or redirect. But to me, there are different drivers in different places. In Florida, it's environmental protection. So there's a new regulation that's going to prohibit wastewater utilities in Florida from discharging secondary treated wastewater into the ocean. So what's beyond secondary? Well, you treat it to reuse levels. So it's an environmental regulation to protect the environment. In other areas like Anne Arundel County, they've tapped out the groundwater to a pretty high degree. So they're thinking about, well, okay, let's treat the wastewater and use it to recharge the groundwater. And in Nassau County, it was also a groundwater issue. So I think, and in some places it's environmental restoration. So let's say wetlands or a river is running dry. So you want to actually be able to restore the environment. And we're seeing that in Northern Virginia. Anyway, John, anything to add to that?
Yeah, I mean, a quick fine point. John, when you and I were on the Water Reuse Foundation board 15 years ago or so,
Yeah.
it was pretty simple. It was California, Texas, Florida, and everybody else, right? And what we're seeing is an evolution of these smaller decentralized systems, 2 to 10 million gallons a day. And that's a commitment, and it takes localized flows and does something positive with it in terms of reuse, right? And that's good. We're also seeing the evolution of the big kids like California, where LA is going to reuse 400 million gallons a day, or Florida basically at the ocean outfall legislation, basically told Dade, Broward, and Palm Beach County, shut off your outfalls and go to some sort of reuse or deep well injection, but you're not discharging into the Atlantic Ocean. So I think that's the evolution, and these small decentralized systems are a great way to start. I'm energized by that.
Okay, so I think in Northeast and non-water scarce areas, it's environmental protection, desire to restore the environment, and actually to recharge groundwater are probably the three principal drivers. Um, and then, okay, we only have 5 minutes left. There's a question here that's to me very interesting, and it's about treating produced water. You know, I mean, if you look at the federal government in the U.S. right now. Um, one of the 5 principal columns the EPA has outlined of its strategic plan is enabling American energy dominance. Their words, not mine. So if that's the goal, one of the ways you can do that is by treating produced water so that you can reuse it to frack for more uh, oil or gas, more often gas. John, thoughts about the feasibility of treating produced water so it can be reused? Is it feasible?
Well, over 50% of the water that we extract for some sort of initial use is dedicated to create power. Conversely, a large percentage of the power consumption is used to move water. You can't get away from the nexus. So when we start talking about, power dominance, regardless of the source, fossil or whatever, it's the generating stations are thirsty facilities. So, I would start with that, John, on how we're going to manage the water power nexus. Forget about the rest of them. And especially when you got programs like in my city, LA, where we're doing an $80 billion repowering to eliminate 4 generating stations from fossil fuels to either natural gas or sustainable power sources. Uh, all of that's going to have a big component of water in the
All right,
equation.
let me just say, because we're down to 3 minutes, let me say in answer to the question, yes, the produced water can be treated. And if you look at the oil sands or tar sands, whatever you want to call it, in Alberta, Canada, there's actually a regulation now that mandates that at least 90% of the produced water has to be treated, and that's in large measure to protect the Athabasca River and to try to restore the environment there. So, yes, it can be treated. It's a question of cost, but the technology exists to do it for sure. Um, I think
Decentralized is the solution, right? I mean, that's the real answer for
we
those isolated
treat it
systems.
well,
Yeah.
and typically. So just to wrap up, I'd like to, John, first of all, thank you for sharing your expertise and your time. And I wish you a good trip to Mexico City, which I know you're heading to in a couple hours. So have a good weekend there. And I want to thank the University of Pennsylvania, the Water Center, for hosting this. And just say, in summary, that if you do look around the world today and you see all this water scarcity, there are things you can do. There's conservation, and John, you mentioned conservation earlier, but that often that's almost always the first step. It only gets you so far. There's desalination. You mentioned desalination as well, John, in Carlsbad, just north of San Diego. Desalination is a great option to have, particularly when you have access to coastline or brackish groundwater, but not everybody does. And it also tends to be expensive, often twice as expensive or 4 times expensive as taking wastewater and treating it for reuse. And finally, you have reuse. I think we're only scratching the surface of what can be done globally. Some places are farther ahead than others. Israel, Singapore, California, all good examples. Um, but it's a great opportunity for the rest of the world to help address one of the defining challenges of our time, water scarcity. And thank you, John, for helping us unpack this issue and discuss it. And thank you, University of Pennsylvania.